And welcome students, my name is Shampa. Today we are going to understand a very important theorem with reference to circles. That is, the perpendicular from the center of a circle to the chord bisects the chord. In order to understand the concept, let's draw the diagram first. So here we have a circle and here we have a chord. Let's take the measurement of the chord. So this measurement is 7 centimeters. Now, this is the center of the circle. Let's call it center O, circle O, circle with center O and radius R. The length of the radius, let the length of the radius be R. Now, if we draw a perpendicular, I'm making a freehand drawing. So, if we draw a perpendicular from the center to the arc, this perpendicular will bisect this chord in two equal line segments. So this is the theorem that we are going to prove. So let's move on. So in order to proceed further, let's join. So this is O and let's join from the center to this point. Let's join these points. Let's call it PQ. Let's join OP and here let's join OQ. Now this is the perpendicular and we will prove it that this is also the perpendicular bisector. So let's call it OR. Now we know we know the concept of congruent triangles. So let's consider triangle ORP and triangle ORQ. Here we have triangle ORP, that is this triangle, and triangle ORQ, that is this triangle. So let's begin. Now we know that this side is common. So OR is equal to OR. This is common. And OP is equal to OQ. Can you suggest me why? Because these two are also the radiuses of the circle. See, this is from the center to the circumference of the circle. So this is the radius. This is also a radius. So these two are the radiuses of the same circle. So they have to be equal. So this OP is equal to OQ, radius of the same circle. And here we drew a perpendicular. We know OR is perpendicular to PQ. Therefore, angle ORP is equal to angle ORQ. So, perpendicular, here each angle is equal to 90 degrees. So, triangle ORP is congruent to triangle ORQ. And which congruence rule is it? This is RHS. This is the right angle. This is the hypotenuse, these two hypotenuses, and this is the side, right angle hypotenuse side. So using the RHS congruence rule, these two triangles are congruent. And because these two triangles are congruent, we can safely say PR is equal to RQ. PR, this distance, is equal to this distance. This is because they are corresponding paths of congruent triangles. So that was pretty easy.